Hi, my name is Edward Thompson. I'm a program manager for Microsoft Visual Studio Team Services, and I focus on Git and version control. I'd like to introduce you to a technology called GVFS. It's the Git Virtual File System, and it's a tool that we've created to allow Git to handle enterprise-scale Git repositories. In this video, we'll take a look at what it means to be an enterprise-scale repository, understand how GVFS works, and see a quick demo of GVFS in action. GVFS was created at Microsoft as part of our company-wide move to Visual Studio Team Services. If you're not familiar with VSTS, it's Microsoft's platform for software development and DevOps. We support the entire software development lifecycle, beginning with planning and ending with deployment to servers. An important part of supporting the development process is hosting your Git repositories. And VSTS doesn't just host your Git repositories, we also use VSTS ourselves within Microsoft. We're standardizing on VSTS as the one engineering system throughout the company, as the platform that hosts our own projects. This includes truly enormous projects like Windows. Now, if you read the Git documentation, it'll tell you that it was made to handle large repositories like the Linux kernel from day one. And to give you a sense of scale, let's compare the Linux kernel to some other open source repositories. The Linux kernel source code is around 650 megabytes and about 57,000 files, which, yes, is pretty big, but as far as enterprise scale repositories go, that's really not all that large. When you compare it to, say, the VSTS repository that contains all the source code, tests, and dependencies for Visual Studio Team Services, we can see that the Linux kernel is a lot smaller. The VSTS repository is about 3 gigabytes on disk and about 110,000 files. But as far as repositories within Microsoft go, that's just the tip of the iceberg. The Windows repository is the biggest Git repository on the planet. When you check it out, it's 270 gigabytes on disk, consisting of over 3.5 million files, and it has 4,000 people working on it on a day-to-day basis. It's been in constant development for over 20 years, and it's the source code repository that we measure all our scale by. And as part of the transition within Microsoft to one engineering system, we needed to support this repository with Git hosted in Visual Studio Team Services. The problem is that Git simply doesn't work in the Windows repository, at least not by itself. When we tried to put Windows into Git, we hit some scaling limits immediately. Even on our incredibly fast network, it took over 12 hours to clone the repository. And once we had it cloned locally, it took over 3 hours to switch branches. It took half an hour to add a file and commit it. And it took a full 8 minutes to run git status to examine the repository, just to tell us that nothing had changed. It was immediately obvious to us that Git couldn't handle the Windows repository. Git does two things that make it scale poorly to large code bases like Windows. First, it downloads all the files in a repository, including all the history of those files. You get a complete copy of the remote repository when you clone it. In fact, that's why the command is called clone. Second, most Git commands look at all the files in a repository. Even doing something like adding a single file means that you need to modify some data structures that contain a list of all the files in the repository. So Visual Studio Team Services and the Windows team have built GVFS to help Git scale, and it attacks both of those limitations. First, it allows Git to download files on demand, as you use them. This means that your initial repository clone is incredibly fast. Git with GVFS will download just the metadata and the repository structure. You'll only download the other files as you need them. And since nobody works across all 3.5 million files, that makes working in the Windows repository incredibly efficient. Second, GVFS sets up what's called a sparse repository. This is a setting to Git that allows it to operate on only a subset of the files within a repository. It speeds up the operation of large repositories significantly, but normally, it's a very challenging manual process to manage this configuration. But GVFS takes care of all the management for you. And GVFS is what makes working in the Windows repository incredibly efficient. Now, when we clone the Windows repository, it takes just 90 seconds. Again, that's downloading just the metadata and the repository structure, leaving those 3.5 million files on the server. So you can get started working in the Windows repository in just a minute and a half. Switching branches, in the worst case, takes only 30 seconds. Running status, something we do as developers all the time, takes just 3 seconds. And adding a file and committing it, just 8. That's an incredible improvement over working in the Windows repository without GVFS. The secret to GVFS is in the specialized GVFS driver technology. In a typical development scenario, you have an application like Visual Studio or your build tools talking directly to the NTFS file system. And of course, all the files that you're compiling need to actually be on your hard drive. Well, with GVFS, they don't. The GVFS driver actually sits between all your applications and your file system. It looks at the structure of your Git repository and uses that information to produce a view of what the file system looks like, even though the files aren't physically on disk. So you can use every standard application. They don't need to be aware of GVFS, and they'll see the file system structure. When they actually go to open the file, let's say src2.cpp, then the GVFS driver will intercept the open call and download the file automatically from the Git server. In this case, Visual Studio Team Services. VSTS will return the content and it will be saved on disk so that the next time you open the file, it won't have to go back to the network. Let's take a look at how this works in practice. Here, I'm going to use GVFS to clone a repository. Now, I'm not going to use Windows. I'm going to clone my open source project, libgit2. Now, libgit2 is not a very big project. It certainly doesn't need GVFS, but I'm using it for a few reasons. First, to show that GVFS works with any Git repository. I didn't need to split it up into pieces or set up submodules. But perhaps more importantly, the Windows team doesn't like me using their repository for testing. So as I'm doing the clone, you can see that it says it's fetching commits and trees. This is important to how GVFS works. The commits and trees are the repository's metadata, the information that makes up the repository's structure. What's not downloaded are the blobs. Those are the Git objects that correspond to the actual files in the repository. So right now, we have the repository structure, but not any of the files. But even though I don't have all the information in the repository, I can go into the source directory and I can run dir. I can actually see the list of files when I do that. So this is the GVFS driver projecting this repository structure. Even though we don't have these files, it appears that we do. I can even open up one of the files like this README and type its contents to the console. Now again, the type program doesn't need to know anything about GVFS. In fact, it hasn't changed much in the last 20 years. GVFS takes care of everything for us. I can even edit this README file. Now, what happened when I opened the file the first time is that it actually downloaded the file from Visual Studio Team Services. It placed the contents on disk, and then it allowed the type program to actually display the file on the console. The next time I opened the file with my text editor, it was still on disk. It didn't need to go back to the network. You can see this if I actually turn off GVFS. I'm going to unmount the GVFS driver's file system. So now there's nothing projecting the repository's file system structure to applications. Now you can see all I have are two files, the Git attributes, which is a Git metadata file, and the README that got downloaded. So that's an important part of the GVFS story, reducing the amount of data that's needed to be downloaded to work in a repository. But there's a second piece of GVFS, and that's managing some configuration with Git. GVFS sets up what's called a sparse repository, meaning that it has a list of the files that should be examined inside the repository. In that list is the files that GVFS has downloaded locally. This keeps things efficient. If a file is not in this sparse list, then Git basically ignores it. And this allows Git to operate very efficiently, as if the repository was much smaller. GVFS is actually managing this sparse configuration for me. If I navigate into the .git directory, into the info directory where Git keeps its configuration, I can actually look at the sparse file. When I look at that, you can see that these are the names of files that have actually been downloaded from the server or edited locally. In this case, it's the Git attributes file, my README, and a couple of swap files from my editor. This is how Git actually limits the scope of work it does. It knows that it only needs to look at the files that are listed here. Usually maintaining this file is an incredibly tedious, manual process, but GVFS actually handles the management of the file for me, adding paths that I request into the file, as well as new files that end up getting created on disk, like my editor's swap files. So GVFS handling this gives me the benefits of sparse repositories, like much faster access to the repository without any of the maintenance overhead. So these two optimizations, when taken together, downloading only a limited amount of information from the server during a clone, as well as the automatic management of the sparse checkout file. These are what allows GVFS to handle enterprise-scale Git repositories. You can read much more about how Microsoft is handling Git repositories at scale by visiting visualstudio.com/git@scale. And you can find out more about GVFS at gvfs.io. We hope you found this useful. You can find us on Twitter at VSTS. Thanks for watching.